So you've been thinking about the idea of measurement, and I've been trying to get you to think about how would we explain the idea of measurement to a young learner. As adults, we might just naturally know. If I told you to go measure this, you would just kind of naturally know what I mean by that. But as you're going to see, as we teach mathematics, particularly geometry, measurement ideas, it's going to be important for our young students to have an idea, a clear idea, a well-articulated idea of what it actually means to measure. Now you'll see this. Right now it's early on. It might not be exactly clear why I'm making such a big deal about this. And I hope that I am making a big deal about it. And two, I hope you see why I'm making a big deal about it as we progress. As you think about measurement, it's going to make such a big difference in how you think about the ideas of geometry that we're going to study, like perimeter, area, volume. So, let me back up again. We'll get to all those things soon. But first of all, just the idea of measurement. Just to kind of recap or to have you think about it once again with me in this video, I'd like you to imagine this. What can we measure? So suppose this is a picture of my now 22-year-old son Zachary back when he was, I think, in 5th grade. And I did a little lesson with his class. And so, of course, I used his picture in this process. But I asked the class, what can we measure? If Zachary was standing in a room with us and I said, hey, let's measure Zachary. Your first question should be, measure what? It doesn't make sense to just say measure unless you're clear about what about Zachary are we going to measure. So I'll pause for a minute here and just kind of in your own brain think, what could we measure if I told you to measure Zachary? Now, this is not an exhaustive list or the correct answer or anything like that. It's just a list of things that I was thinking about. We could certainly measure Zachary's height. We could measure his weight. We could measure his blood pressure, his age, his temperature, his body fat, his strength. There are ways in the, I can't think of the name right now, exercise science. That's what I was trying to think of. Exercise science. There are ways to measure strength and flexibility. You could measure surface area. There's ways to measure, and sometimes people want to, for biological reasons, to measure the surface area of skin, for example. But whatever it is that we want to measure, what would it mean to say to measure? Well, to put kind of scientifically, it means to engage in a process that would assign a numerical value to some spatial or physical attributes. Think about that in the context of the items on this screen. If we were to measure Zachary's height, we would engage in some process and we would assign a numerical value to Zachary's height or weight or age or temperature. But in all of those cases, there's going to be a specific thing that we would have to do to measure. Now, before we get into that more specifically, I want to remind you of what it means to multiply. You'll see why. We're going to connect these two ideas here soon. But what does it mean to multiply? So multiplication sometimes is thought of as repeated addition, and that can be good, but it's not as robust as I would like it to be. So I'm going to have you think about multiplication as copies of. See, there's one copy of that picture of Zach, and now there's 2 copies, 3 copies, 4 copies, and even like 4.5 copies or something of this picture of Zachary. When we talk about multiplication, like if I say 3 times 2, what we're really saying is make 3 copies of 2 things. And we can do that with fractions too. Like if I said 3/4 times 7, it says make 3/4 of a copy of these 7 things. Don't do a full copy, just do a 3/4 of a copy. So multiplication is this idea of copies of. How many copies of do we have? 5 times 3. I have 5 copies of 3. Now that's going to be important with multiplication, with measurement, because here's the full process now To assign that numerical value to a physical attribute or some spatial measurement, we have to engage in this process. Number one, be clear as to the attribute to be measured. Like, you can't say, measure Zachary. You can't say, hey, could you please measure that desk? What about the desk would you like to have measured? Its height, its width, its surface area, its weight if you had to pick it up? So first, before you engage in any measurement, be clear as to what you mean in terms of the thing you want to measure. Okay, so for example, measure Zachary's height. So I'm clear about the attribute, the characteristic, if you will, that I'm wanting you to focus on when you measure Zachary's height. Now then, what we do next is we find something that has the same attribute as height. For instance, this pen has the same attribute as height as Zachary has height. So I'm going to use this pen as the measuring stick to measure Zachary. Now what I'm going to do is compare multiplicatively. Now that's where the multiplication comes in. What I mean is, how many copies of this pen stacked end to end would it take to measure Zachary's height? Can you imagine? If Zachary was standing next to me, I would put the pen at his bottom of his feet, and I would maybe mark where the top of the pen is, and then I would put the pen up the next, I would mark, and I put the pen up the next, and I would mark, and I would mark and mark, and I would say, hey, look, Zachary is 27 of these pens tall. Multiplicatively, how many copies of this pen does it take to stack end to end to match Zachary's height? That's what we do anytime we measure. Is first, we're clear as to what we're measuring. Second, we find something else that has that same attribute. And third, we compare multiplicatively. Now, after this video, we're going to pause and have you connect this back to the pencil that you did. But that's just the idea of measurement. And so imagine this, in any of these cases, we're going to end up doing those three things. If we're going to measure Zachary's weight, first of all, there's the attribute weight. Second, find something else that has the attribute of weight. We have some standard things, like 1 pound in the US. If you travel outside the US, it would be like 1 kilogram. So can you imagine a 1 pound something? And then third, compare multiplicatively. How many copies of 1 pound would it take to be equivalent to Zachary's weight? So anytime we measure, that's what it is that we're doing, is we're asking the question, how many copies of some standard, like the pen, like the weight, 1 pound, how many copies of that does it take to create the thing that we're measuring? So that's what measurement really is. We'll pause there and have you connect it back to your pencil activity in the next activity.